Hey everybody, and welcome to our practice round. So this is like a supplemental thing. I just made these numbers. I don't even know what's going to happen when I crunch them, but I wanted to give us some room to practice for things that you would probably see on a quiz or on the exam. So you're going to see that these look very similar to where the last video left off. So let's go ahead and knock those out first. So we'll do the Z-score business first, then we'll do the conditional probabilities after that. So let's go ahead and start this up. So find the area under the curve below 1.42. Now remember, I love drawing these things out just to make sure that I'm on the right track, because it's easy for me to visualize. You'll know when you go wrong usually. So we got 1.42 here. So I'm looking for everything below that, right? So I know it's going to be, just eyeballing it now, I know it's going to be over 50%, right? So I know, if I get a number and it's less than 0.5, I've done something wrong. So let's find out. 1.42. I'm coming over here, throwing in 1.42. That's going to give me, above it is going to be 0.77, which you can see right there. You can confirm that on the distribution. So 0.077. So that's going to be equal to 0. I already forgot. 0.077. Okay. And if usually I would just round that up to the nearest hundredth. I don't need to be fancy about it. So it's very rare, right? Basically, actually, this is why I'm so glad that I just gave that little speech about why it's so necessary to look at these figures like this, because 0.08 is not even close to 50%, and I know that it's going to be more than 50%. So let me double check what I did. I must have done something wrong. I put in 1.42. And I looked at greater, and that is my problem, is that I was looking at everything above that point and not everything below that point. Everything below 1.42 is actually 0.92, which is quite high. So everything below this is not going to be that. It's going to be 0.92. It's going to be, yeah, everything right here, which is a lot of the distribution. All right. So the next piece here, find the area under the curve for z equals 0.6. So let's find that out. And actually, before I do that, I'm going to continue doing this business about drawing out a distribution, because it saved my butt on that previous one that we just did. So here we go. So 0, -1, +1, -2, +2. All right, so area above negative 0.6. Negative 0.6 would be somewhere right around here. So again, we're looking at more than half the data if it's going to be above that. So let's find out what that is. I'm going to throw in 0.6, calculate that, and I'm looking for everything above that, right? Which is what I see right here. And that's going to be 0.725, so 0.73. Because what we're saying is that everything above this is about 73% of the data, which just eyeballing it does look to be correct. Then now finally, this next one, find the area under the curve between z equals -1.96 and positive 1.96. So I'm basically looking for way out here. So what is the total data that encompasses this part of the distribution? How do I find that? And I'm doing 1.96 for both. It's actually easier than you think. 1.96. The way to do that is to just look at this last one. This last one down here is what happens if you were to do 1.96 and -1.96. What this tells us is essentially that on, what's the likelihood of getting above or below that z-score is going to be about 0.5%. Which, if you think about it, the reason why I chose that specific number is because if you think about the empirical rule, right? If it's, the things that are If it's 2 standard deviations above or below, that is going to be roughly 95-96%. And so I put in very, very close to 2, right, and negative 2, and we got something very close to 96. We got 95, which is perfect. So I'm going to say that that is going to be 0.5. So that everything here is about 95%, which means, yeah, that is what the question was, looking at 95%. We would say then that everything on the other side of that, over here, is going to equal up. So both these combined are going to be 5%, which means that it's 5% below and 5% above those markers right there. Alright, so then the last part of this is doing conditional probabilities. Now before I even start calculating a bit of this, I'm going to calculate the totals, because that's always going to be the first step. So I'm going to be adding across, and I guess I should say what we're looking at here is a table that looks at depression diagnoses and then what age that client is, if they are teens, 20s, or 30s. For the sake of simplicity, we're going to assume that these are mutually exclusive categories, where even though depression and anxiety are often comorbid, so they often do occur together, we're going to assume for the sake of this demonstration that you either have a depression diagnosis, or an anxiety diagnosis, or you have no diagnosis, but you can't have both, or you can't have a combination of those. So first thing I'm going to do is I'm going to get the totals, and I'm going to do that for both sides here. Alright, so I'm going to add across here, so 20 plus 30 plus 100, so I'm going to be 150. This means that there are a total of 150 teenagers in the study. Now for this next one, we got some higher values, so 2300 plus 5600 plus 10,000 is going to give me 17,900. So we see hugely disproportionate sample sizes inside this sample. There's way more 20-year-olds than there are teenagers, and people in their 30s, because when I add this up, 10 plus 20 is 30, 30 plus 80 is 110. Okay, cool. Now the next thing I want to do is I want to do the same thing but for the columns now. So I'm going to go through, and 20 plus 2300 plus 10 is going to give me 2330. My anxiety diagnosis is going to be 30 plus 5600 plus 20 is going to be 5650. And a no diagnosis is going to be 100 plus 10,000 plus 80, and that's going to give me 10,180. Alright, so now's the moment of truth, right? I should be able to add these up, and then that gives us the same thing for both of these. So I'm going to add up the totals for the teenagers, 20-year-olds, and 30-year-olds first. So I'm going to do 150 plus 17,900 plus 110, and that gives me for these 18,160, and oh boy, I really hope that it goes across just as well. So 2330 plus 5650 plus 10,180, and lucky us, 18,160. So we get it going across and going from top to bottom. We got the same totals. Perfect. We added correctly. We're ready to do the dirty work now. So what is the probability of being a teenager? So what is the probability of being a teenager here? To answer that question, all we have to do is, and this is why this is a little bit tricky, is that like if you just saw this on an exam, you may think that the answers you need are somewhere in these numbers, but they're not. You actually have to add up and find the totals in order to calculate that. So in order to say what's the probability of choosing a random data point from this sample and having it be a teenager, that is going to be 18,160, which is our total number of occurrences, divided by the total occurrences, which is 150, or occurrences of being a teenager. It's 150, and so I'm going to divide that up now. So 150 divided by 18,160, and that is going, oh wow, that's so low, 0.008. That's really small, y'all. So basically the probability of being a teenager is 0.8%. Not 0.8, because that's the probability, and that's 80%. This is the probability, 0.008. I converted it to a, actually, hold on. Yeah, that's right. If I converted it to a decimal, or sorry, to a percentage, it's 0.8%. Very, very small probability of being a teenager. What is the probability of having an anxiety diagnosis given that you were in your 30s? So how would I answer this? So what I'm doing here is, if I know that we're in the 30s, then we're just going to be looking at this row right here. So we're just going to be analyzing this stuff right here. So what's the probability of having an anxiety diagnosis? So I'm going to be focusing on this in my 30s. So I am going to do 10 divided by the total number of folks that are in their 30s, because that's a given, and that's 80, and that's going to give me 0.8. Or, wait, hold on. I did something wrong. What did I do wrong? Oh, I see what I did. Okay, yeah, so I screwed this up. That's not correct. Could you figure out where I went wrong? Because we're looking at the 30s, it should be 110. So it's going to be 110. We had 10 cases, which is going to be something a little bit different here. So 10 divided by 110 is going to give me 0.09. So the likelihood of having anxiety when you are in your 30s is about 9%. It's a 9% likelihood. All right. Now, so a really cool question then would be like, if we control for the year or the age, which group is most likely to have an anxiety diagnosis? Oh, and actually I screwed up. You're probably yelling at your computer already that I plugged in the wrong numbers again. And I just noticed that. So I'm looking at anxiety, which is 20. So it's 20 over 110. My apologies. That's going to be 18%. Which makes sense, yeah. So 18%. All right. So now, the bonus question that I have here then, and that's why it's good to always check your work, and to show your work so I can give you partial credit on exams. So if I want to know which of these age groups is most likely to have an anxiety diagnosis, controlling for age, the way that I would do that is essentially look within each of these rows, take the anxiety, and then divide that by the total, and that'll let me know for each age group how likely is it to have an anxiety diagnosis. For the 30s is 18%. What about for the 20s? To do that, I would divide 17,900 by 5,600. Or maybe the other way around. I should write that out. It's 5,600 divided by 17,900. And so when I do that, that gives me 0.31. So that's 31% for the 20-year-olds. And what about for the teenagers? This one also a little bit easier. It's just 30 over 150. So 30 over the total number of teenagers. 30 divided by 150 is equal to 0.2. And that is 20%. Okay. So why is this important? What is the point of doing this? Because sometimes in our samples we're not going to have equal sample sizes for all demographics. In this case, we had a lot of 20-year-olds, way more 20-year-olds than we did teenagers or 30-year-olds. So if you were just looking at the total number of people that had anxiety, of course the 20-year-olds are going to show more because there's just more of them. So doing it this way, what you're doing is you're controlling for those specific ages. We're saying, all right, just for teenagers now, what's the likelihood of having anxiety? Just for 20-year-olds, what's the likelihood of having anxiety? Well, just for 30-year-olds, what's the likelihood of having anxiety? And this gives us 20, 31, and 18 respectively. So we would say that 20-year-olds are more likely to have anxiety than any other group when you control for age. Teenagers are going to be second most common, and the 30-year-olds are going to be the least common. All right, I think that's pretty much everything we can possibly analyze here. So thank you so much for watching. If you have any questions, let me know. Otherwise, I will see you later.